When it comes to multiplication, we do need something first. Multiplication. I do need to get my words that are that fit with this concept. Now, most people, by the time they get to school, they've had some exposure to fractions, even if it's just a half. So take a half, uh, if that's the only familiar fraction. If I say, let's say we have some instructions. I give an instruction. And that instruction is, I'm hesitant to use the word take because we use take away with subtraction, but I'm going to take 1/2 of, let's say, 4 pencils. I put 4 pencils on the table in front of little Timmy. I give him the instructions, take a half of what you see. There's no doubt he's going to then take 2 of the pencils. So when I make the fraction as easy, as intuitive, and familiar as it can be, I think a half is probably the easiest of all fractions. What we're doing is not difficult to intuitively understand what the instruction is asking. Now the corresponding calculation to take a half and 4 and give me a 2 is, of course, a half times 4 equals 2. So this means that this multiplication operation has a key word that helps me intuitively understand what the instructions are. And that key word is of. Take a half of something. Of is the key word. That, in my experience at least, when you use that word, knowing what to do is much more obvious. That if I say, take a portion of something, everyone's going to know what to do. Okay, just what portion do I have to take? And the calculation that is behind that is the multiplication. Now, this only works when I have a small fraction at the start here. So here I need to have a fraction less than 1, because I'm only taking a portion of some quantity. Okay, but this second number can be any number. It can be any number because it can be any quantity. Okay, so when I read a multiplication like this, and I now have to intuitively figure out what to do, I think of the of word, and the instructions are telling me I have 4 pencils. This is what we have. I have 4 things. Take a portion of that. So the second number in the multiplication is the quantity that I have, contrary to what we've seen before. I now have to remember that if I want to intuitively interpret a multiplication calculation, the second number represents the quantity that I have at the beginning. Why? Because of this. Take simple numbers that Timmy will intuitively understand what to do. And in demonstrating this instruction, you start with 4 pencils on the table and then take a portion of that. So the second number is the number that we start with. So now let's see, when we get to fractions, how are we going to structure this? How are we going to lay this out so that it presents well? So let's take 1/5 times 2/3. Just start with both proper fractions. So now we know the second of these is what I have. So let's represent that. I'm going to give myself a little bit of space in front of it. Like so. Now again, I want to represent 2/3, right? So I'm going to break it up horizontally into 3 pieces. That's not very good. It's better. And I have 2 of them. 2 of the 3 pieces is what I am starting with. All right. That's what I have. I have the pink stuff. Now the instructions say, take a portion of that. So this 1/5 is now followed by another fraction. It's not in reference to a whole rectangle. It's in reference to the pink that I have. So I need to take. Now, if you want to use another word than take here to have it be more distinguishable when I think about subtraction, feel free. I can't think of a nice intuitive word to use here, but it shouldn't be mixed up with, oh, this is take as well, so this is another version of subtraction. No, it's not. I need to take 1/5 of, I'm going to write it in pink, what we have. In multiplication, the first fraction is applied to what I have. All right. So now, how do I know how much I need to take? I'm going to go 5 rows horizontally again. That's my answer for everything. So let's do it here as well. So 5 is a little off center. I try and make them as equal as I can. So this 1/5 means 1 out of 5 rows. In my case, I made rows. So that means I might as well take the top one, and only 1 of the 5 rows I have available. It doesn't matter which one. They're all identical. So what do we then take? Or get, or whatever. Let's use get maybe. We get to keep 2 pink pieces. And it's important here that you make them pink. This guy over here, he was never something I had. So I can't take this one. I only take 2 because those are the only ones that are pink. All right. Now, just like before, my answer is going to be a fraction in reference to a whole rectangle. Standard sentence. It takes 15 pieces to make a whole. So we get or took or whatever, or I don't want to say left with. No, I don't want to do that. 2 15ths of a whole rectangle. I'll write that down. Of a whole rectangle. Different? Yes, for sure. And our goal here is to make it as intuitive as possible, in the sense that you don't need any other knowledge, any other trick, any other property, anything else to be able to figure out the answer as much as we can. We do need to understand the instruction in words, of course, because we're doing an explanation in words. So we do need to understand that the instructions here are take a portion of something. So then I represent the something, figure out how much I need to take of that something, take it. That's what I walk away with. I take it, walk away. And then I just want to figure out, okay, how much of a rectangle did I walk away with? 2/15. Okay. And that's multiplication. Multiplication, I think, is a step up. And it's unfortunately going to get worse. So it's very important that you understand these first ones perfectly. Otherwise, what's coming up, probably tomorrow, will not be so much fun. So let me just see my time here. 18 minutes. Yeah, I want to do number 2. We'll just do these as far as we can. If we get to all 3, great. But if we just do 2 of them, that's okay. So I have my fraction multiplication. That means I start with the second quantity. Happens to not be a lot, that doesn't matter. I still represent it. 4 vertical slices. Half of a half, like so. Let's color it. Pink, why not pink? I don't have a lot. That's all I have, unfortunately. Now the instructions now say we need to take, or we get a portion of that. Let's say here, we get 5/6 of what we have. Only of what we have. This fraction is followed by another fraction. It's in reference to that fraction. It's applied to that second one, not applied to a whole rectangle. So I need to make 6 rows so that I can take 5 of 6 rows. Because I've used columns, it's going to have to be rows. 5 of 6 rows. Let's make the rows. Cut it in half. And then into 3 each half. The bottom ones look a little bigger. Whoops. Just squint. They're supposed to look the same, of course. It's not always that easy. So 5 of the 6 rows. Okay, good. 1, 2, 3, 4, 5. Not that one. I just go from the top. It doesn't matter. So it's a lot of rows we can keep, but it's not a lot of pink. I only get to keep what I have. Oh, choose from what I have, which is 1, 2, 3, 4, 5. So we get, maybe get's a nicer word, 5 pink pieces. I didn't have much to start with. I take a large portion of them, but it wasn't a lot. Now my standard sentence to figure out how much of a whole rectangle is this that I'm getting. It takes 24 pieces in general to make a whole rectangle. So we got 5/24 of a whole. Once you get the hang of it, it's just really quite straightforward. But there was a new instruction that we have to, of course, get used to. And on the far left, basic, intuitive side, we can't rely on anything else. Anything else. Alrighty. Let's do one more. Let me just think what I want to do. I forgot to talk about properties, but I think maybe we can do properties at the very end. I don't want to mix them here. The whole point is to not use mathematical properties to find the answer. So we're going to do those at the end by illustrating, okay, after we've done addition, after we've done subtraction enough times, eventually we want little Timmy to start noticing a pattern and see those properties and discover those properties that he can eventually use when the numbers get uncomfortably big. We can use this method to discover those. Same for multiplication. But when we do this, at this stage, we don't have those properties. We have not discovered them yet. So let us do number 3. Now, as I've said here, for now, we have to look at the other side of the multiplication. There's good news and bad news. The good news is that multiplication is not that hard. Take a portion of something. I feel that's fairly intuitive. The bad news is there are 2 sides to multiplication, and it all depends on what this first fraction looks like. Right now, we are restricting ourselves to taking a fraction or looking at a fraction first that is less than 1. It's a proper fraction. Don't make the second number a mixed number. Sorry, don't make the first number a mixed number yet. That's a slightly different intuitive story instruction. But the second one can be anything. That's simply what I have to start with. So let's look at 2 1/4. That's quite a bit. So for now, that first number is going to be a proper fraction. We're going to have to wait until tomorrow to see what happens when I make the first one a mixed number as well. Can't do everything at once. So just like before, I have 2 whole rectangles and I need to split up the last one. I don't have any need to split up the first 2 yet. Why would I? I'm not going to make lines just because I want to. I have no need. I have the whole loaf of bread. I'm not cutting into it until there is a very good reason to do so. So I have the whole second one as well, and then a little slice of the last one. I have a lot. Nice. Now my instructions say take a portion of that. So we get to take, or whatever keyword you want to use here, we get 2/3 of what we have. Let the color help you. What we have. Now 2/3 can be interpreted as 2 of 3 rows. So for that reason, I have to split everything up into 3 rows because I need to take from all the pink. So let's do it. It's 1, 2, and 3. All right. So let's do that. I get 2 of the 3 rows of pink. 1, 2, not that last one. So I get to keep quite a bit. It's not bad. However, not all the pink pieces look the same. For that reason, I do need to split up everything vertically as well. Now I understand why I need to do that, though. I didn't at the beginning. Now I have a reason to do that. I'm not going to do anything just for the sake of it. There has to be a reason. So now they all look the same. Okay, that helps. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, and another 9. So we get not 9, 18. We get 18 of these squarish pink pieces. That's quite a bit. It's not bad. I just now need to put that in reference to a whole rectangle. It takes my standard sentence. It's going to be 12 pieces only. I can count them off, whatever. It takes 12 pieces to make a whole rectangle. We got to keep 18. Very nice. So we get one whole rectangle, or enough for one whole rectangle. I can put my pieces back and, like a puzzle, make a whole loaf of bread. And another 6 pieces. Of course, they're all pink. Maybe let's make them pink. That's pink. That's pink. Everything's pink. We only take from the pink. Right? Because, oh, excuse me. Oh. I got a little emotional about getting so much bread. It's so beautiful. I'm so hungry. I get enough to make a whole loaf of bread and still have 6 left over. So, finally, we get or got or whatever 1 and 6 twelfths, because 12 is my standard amount that corresponds to a whole rectangle, one whole one, and another 6. Now again here, I'm not going to break that into a half. Where do you see 1 and 2? No, I see 6 and 12. That's what I see. And it's people's obsession with simplification that's going to confuse little Timmy. He doesn't see a half. This simplification is not important here at all. I really can go on a rant for probably an hour about how people are conditioned to simplify everything they see, and it is, what's the word? Well, it's kind of stupid because it's misguided. It's not the point. Just because I can do something doesn't mean I should do it every single time. There's nothing wrong with this fraction. 6 over 12 is a perfectly good fraction. I'm not going to discriminate against fractions. It's not nice. There's nothing wrong with this fraction. I do not want to see a simplified answer here. That is not the point. And then I have to question, if you simplify this, I have to question, do you really understand what we're doing here? Do you understand the point of what the question was asking? Because if you simplify, I don't know if you do, because that wasn't the question. So you want to present your answer in a way that convinces me that you understand what is happening here and you can explain yourself clearly. All right. I think that is enough in terms of examples for the first half of multiplication. It's not the whole multiplication. We do need to have a look at what happens if I can have any number first. Well, we haven't fully explored that. We're going to have to do that tomorrow. We have to be ready. Well, what if the first number is a mixed number instead of a small little fraction only? So let's continue our multiplication. Multiplication continued. First, we try and keep things as intuitive and natural feeling as possible. That's our goal here, right? So imagine we have 4 pieces of candy. Ooh, now can I draw candy? Ooh. 4 pieces of candy. There's the candy wrapper. It's not going to look very good. There's my candy that I put on the table for little Timmy. I'm obviously an immensely talented artist. That shows every time I pick up a pen. I put 4 pieces of candy in front of little Timmy. Okay. If I tell him, take a half of what you see, he's going to know what to do, because this is a fraction. This is a proportion, a portion of what, call it whatever you want, that he has heard of before just in speaking and building his language. So let me just update this. Like, this is multiplication, right? So we've associated the of word with multiplication, taking a portion of that. Okay. But if I put 4 pieces of candy on the table in front of him, and I tell him, you're going to get 2 times what you see. And then you ask him, how much candy am I going to give you? He's going to say, you're going to give me double this, 2 times what I see. I'm going to duplicate what I see. So when the first number is a small little fraction, I don't get more than what I see. I get to keep some of it. And I just take that, walk away. Compare that with when the first number is bigger than 1, then what I actually end up with is more than what I see in front of me. I am sort of doubling it up. I am duplicating it a certain number of times according to that number. So this first one is, let's go with get. I'm going to get a portion of 4. The second one is I'm going to get to duplicate. Let's not say 4, let's say of what we see. Of what we see in front of us. We get a portion of it. The other one is we duplicate what we see and get to keep all of that. And hopefully there's a bag behind the table that can give me more, because you told me I'm going to get 2 times what I see, so I'm waiting. So these two even though they're both multiplication, intuitively they are not the same. So as long as I'm aware of that, it's not that bad. So unfortunately, multiplication has this different kind of interpretation when I'm on the far left. Of course, mathematically speaking, there's no difference between these, but that's not where we're at. We're on the far left, where the calculation needs to be viewed in a natural, intuitive, basic way with no shortcuts. Then, unfortunately, the downside is that these two are different, and I should see them and explain them and think of them differently. Now, luckily, by the time I get to fractions, little Timmy would have already done 2 times 4, and he's comfortable with how to see that intuitively. So it's really only 1 added, and the fact that it's interpreted differently is, in my experience, not that big a deal. So let's see by example how we're going to handle this. We just have to be aware of the difference in intuitive understanding when that first number, or depending on that first number. So we have some exercises. Where are they? 14.8. Exercise 14.8. Might as well do the first one. Actually, I'm going to do the second one. Do the second one first. 2 5/6 times 1/4. Remember now, it doesn't matter what that second number is. It only matters what the first number is in terms of how I approach this. All right, so the second quantity is what I see in front of me, let's say. So now I'm just going to do it on the side here. Let's do it over here, like so. I can see the 2 5/6 as 2 plus 5/6. Let's say it like this. Applied to what we have. So that means I need to apply the 2, and then I need to apply the little fraction portion, and then put them together again with my intuitive addition. All right, so let's say we're going to split this up like so. I have a little divider line here. First, I'm going to take 2 times 1/4, and then I'm going to take a little fraction portion of that mixed number. And it's going to be done separately, and then I'll merge them at the end. So 2 times 1/4 means I want to see my fraction, and I'm going to double it up. So I'll just draw them twice, like this, one below the other. So there's not much to do here. I just want to represent the 1/4 fraction this many times, and that's what I get to keep. So I'm going to split it up vertically in terms of the denominator, of course, just like always. Half is a little wobbly, but that's okay. I try and make them equal, but of course it doesn't have to be perfect. And then I'll use some color. And we get to keep one slice and a copy another slice. So that's what we get from the whole portion side. Then the other side is now our previous multiplication approach, where I do have, not pink, well, I guess pink's okay. Pink is what I have. This is now separate from the left side. Different argument here. I have 1/4 to start with, but let's just make that black. And then my divider lines, making it into 4 pieces. Of course, I have one of them. There we go. Now this is the more complicated side, so this is where I need some words, perhaps. Not perhaps, definitely. So I get, on this side, I get 5/6 of what we have, of the pink. That means 5 of 6 rows, because I've used columns. So I'm going to go horizontally 6 pieces. So split it in half, and then each half into 3 pieces. This tells me I can keep 5 of them. Ooh, that's not bad. So that means I get 1, 2, 3, 4, 5 little pieces, because only from the pink I can take 5 little pieces. Like so. But now I see that the left side pink pieces and the right side pink pieces, they're not the same. So putting them all together into a single answer is going to be a little problematic. And for that reason, I have to go to the left side and split them sideways into 6 slices as well. For the left side, I had no need for 6 anywhere. But because I need to make the pieces comparable to see how much I actually have to walk away with, I kind of need them to be the same size. So it's important to not just split these up when you feel like it. There has to be a reason for it. And now there is. A little annoying, but it's only 6. It's not that bad. And then the other one as well. Almost there. All right, so now I see here, from this I get 1, 2, 3, 4, 5, 6, double that. So I get 12 pieces. Yes, they're pink, sure. Doesn't matter as much now moving forward. So more brackets. All together, we get, of course, 17 pieces. Now again, just like always, I need to put this back in fraction form. So my standard sentence, it takes, I can look at any one of these now, luckily, 24 pieces to make a whole rectangle. We have 17, so we get, I'm trying to use a different word, not have and not take, because those are sort of reserved for other things. 17/24 of a whole. Different, yeah, but also not. Let me zoom out a touch. Also not different. It's just there are 2 sides to the calculation, 2 sides to the argument that I sort of have to do in parallel and then put them together at the end. So different, yes, something I definitely have to keep in mind, but no single part of it is really new. It's just 2 things at once. Now, I don't think we need to do 4 of these, but let me know if you really want to. We certainly can. But because they're so similar, I don't know if we need to. Let's see which one should we do next. I'm going to do one more. I don't think there's a need for too many. Let's go with number 3. 1 2/3 times 2 1/4. Oh, a quarter again? Whatever, doesn't matter. Just a fraction. All right. So remember now, I am applying some adjustment, some instruction on the 2 1/4. So this is going to split into 2 instructions, really. One is I have 1 times 2 1/4, and then I get to also take 2/3 of 2 1/4. See how much I end up with. So I only get to keep the 2 1/4 once, but it's better than nothing. So, of course, the annoying part when we're working with a lot of mixed fractions here is that I have to draw a whole bunch of rectangles. And I might not be able to squeeze them in very well, but let's try. Yeah, I don't think I'm going to squeeze them in. Yeah, I'm going to have to stack them a little bit, and that's okay. Now, at this stage, remember, I don't need to necessarily split up all of these into 4 slices because I have 2 holes already. So as far as I'm concerned at this stage, this whole rectangle, I'm getting it. Ew, nice. I'm going to get a lot. But not that last one. I only get a portion of it, so I do need to split that one up. So yes, after you've done this a while, it gets a little tedious. Not like that. And certainly when you get the hang of it, it is just a hassle to draw larger mixed numbers when what we're doing doesn't really change. So I get a whole bunch. Okay, we'll see what we get in a second. On the right, I have a lot to work with now. It's a little unfortunate. It's not going to be in a nice line, so I just have to be careful here, but that's okay. Do it like that. Try to make them as equal as possible. First one doesn't look quite the same, but it is. Oh, whoops. I don't need to color it at this stage, right? I mean, I don't need to split it up. I have all of this, and some of the last one, sure. So let's definitely split that one up. So you might think like, oh, well, isn't it a little silly? I already drew the same thing. Yeah, but I'm going to do stuff to this one, and I don't want to mess up what is contributed from the left side. So it's better, in my opinion, to do a duplicate. So this is what I have. So now let's write down some sentences. We get to keep, or whatever keywords you want to associate here. We get 2/3 of pink stuff. Two-thirds means 2 of 3 pieces, and I'm going to choose rows as those pieces because I have columns already reserved for something else. So I'm going to have to make rows of 3 here. Almost there. 3 is not that bad, luckily. Like so. Now, these are technically all in line, right? So I get to keep 2 of the rows and not the last one. But in order for me to see what I keep, it's not quite as clear entirely. You can now take a shortcut, and it really depends on your audience. You can say here that not all of my whole rectangles are going to get broken up or are broken up. I'm eventually going to merge all these together. This first whole one is going to stay whole, and this one. Sure, I have to do something with that. So I don't ever have to split these guys up. On the right here, I have a shortcut that I can take if I'm comfortable to do so. Now I can say, if I look at this first rectangle here, I keep 2 of these rows and I lose one of them. And then I keep these top 2 again for the next rectangle. I can make a hole by sort of moving this one that way and fill another rectangle. And then I get to keep 1 of this middle row I get to keep as well. That might be a little confusing. Let's do sort of a halfway in between these two. Can I go back? No, I can't click the undo button. I don't want that arrow there. Get away from me, arrow. Let's do let's meet in the middle and say we keep the whole rectangles on the left, but on the right we just do our thing. Okay, so in order for me to see what I actually have, I need to split them up vertically as well. And I'm just going to do it throughout. That's, of course, going to be in 4 pieces. 4 columns, 4 columns, 4 columns. Now, I know eventually, let's leave it for now. I wanted to say eventually I need to split this up as well. But at this stage, I'm going to finish my right-hand side first. So we get 1, 2, 3, 4. Another 4 is 8, 12, 16, and another 2 is 18. I'll remind you they are pink. Okay. We also get some stuff here on the left. And I can't quite make sense of this little slice here and compare it to the little square pieces. So I'm going to have to split that up. But I'm not splitting up the holes. They're not going to get broken in any way. Oops, no, it was thirds, right? Alrighty. So now here, let's separate this nicely. Here we get 2 holes. Oh, come on. 2 whole rectangles and another 3 pink pieces. Okay, now we're close to the end. That we can say now all together. All together, we get, so far, 2 whole rectangles and another 21 pieces. So now I want to see how much does it take to make a whole rectangle. Standard sentence, it takes how much? 3 rows of 4, so 12 pieces to make a whole rectangle. And we have 21 pieces floating around. So I can definitely split this up into 12 and 9. This 12 will be another whole rectangle, and the 9, unfortunately, is not enough. With my 2 holes, I actually got, so we get 3 whole rectangles and 9 twelfths of another. Again, I don't want to sound like a broken record, but I am not simplifying that. Go and watch the other mini rants if you want to know more. And there we go. We got a lot because we took a lot. Or no, that's not the reason. Aw, silly line. We applied our instructions to quite a bit. We get to keep a copy and then a significant portion of that same amount. So it makes sense that we end up with a nice amount. Now, feel free to correct me, but with this being so similar to what we've done before, I don't necessarily think we need more practice. It just takes time to split it up and draw carefully and so on, especially with the mixed numbers, especially with the bigger denominator. It just takes time. But the concept of what we're doing here is not really new. I just have to realize that with a mixed number as the first one in my multiplication, the intuitive understanding of the instructions, that comes in two parts, and I have to split it up accordingly. And if I haven't thought about this before, I sit in front of little Timmy, and I need to explain mixed number multiplication on a basic level, I'm not going to know what to do. I'm not going to know how to explain this effectively. It's going to sound very confusing if I haven't prepared and thought about it for myself. What does this multiplication mean? What is it telling me to do? I need to think about these things beforehand. So what happens? People do have to do this. They're not prepared. They're anxious. They don't really understand. So they just use the shortcuts. And Timmy never gets to build up his number sense and understanding of fractions. And he gets anxious too because he doesn't really understand fractions either. And so the cycle continues. But we can stop it. But it requires of us to think about these things. And the more basic it becomes in my explanation, sometimes the more difficult it becomes. Because I don't have those shortcuts and those mathematical properties to rely on to make it look easier than it actually is.
Please remember to click the like button if you enjoyed the video, and to subscribe if you want to be notified of more videos. Thank you.